Okay, so first of all, I'm gonna quickly go through the Google Doc. The link is also on the Etherpad. You can find, or you can log into Zoom. I'm sharing the desktop on Zoom as well. So I will go through the document, and then let's see what are you guys thought on this proposal and how we can proceed. Okay. Okay. So the kube-acc proposal is about. We have. Okay. So the kube-acc proposal is about the same proposition of Cyborg project as applied to Kubernetes. So at the moment, Kubernetes has a decent basic support of accelerators for GPU and some limited other kinds of devices. But the core problem is that everything is still a silo now in Kubernetes. So for example, if you're using NVIDIA GPU, you need to develop a NVIDIA GPU device plugin interface plugin, DPI plugin for that. Okay, second of all, you need the NVDocker that hacking of the runtime to be supported. Third of all, probably you need the operator for all the GPU lifecycle management, which just source I think October 21st, something like that. Okay. So that's what you do with the GPU. And if you happen to have like Intel FPGA, you need to do the same thing all over again. So you need a Intel, let's say A10 FPGA DPI plugin, some figuring out on the CRIO on the runtime side, and also a CRD or operator to operate the FPGA. And God forbid you have other kinds of accelerators. So it's like chimneys or the silos all over again. So it's the similar issue like we envisioned in OpenStack like 2 years ago when we started the Cyborg project. So for small size users or enterprise, it's not that big a deal. So for a small company, chances are they're just using NVIDIA GPU, right? So we just need one kind. So it will work perfectly okay. But for large enterprises like telco operators or like iFlyTech in China, or I assume any like Netflix or other, or like large enterprises, you either by regulation required to purchase different kinds of accelerators to avoid vendor locking, or your company policy will demand that, or just for the sake of cost efficiency, probably you don't want to like solely relies on just one kind of accelerator. It's really expensive, and sometimes the combination of different kinds of accelerator really pays off, right? So I think this is the core I think problem we are targeting in Kubernetes at the moment with this proposal. So in the motivation section, at the end of it, you can see these are the core motivations. For example, we would really like one common general management framework for all kinds of accelerators in Kubernetes, so that you don't have to learn it and then again and again for different type of things. Similar to Cyborg, we offer general management framework in OpenStack. And second of all the lifecycle management should be done through the extended API via CRD, or we have a unified operator to help with that. Instead of, now if you have FPGAs, for example, you have to do many hacking things like running sidecars for the lifecycle management. I think possibly we will have new requirement on the CRI, on the runtime side as well, if we can offload many tasks to run on FPGA or GPU or ASIC chips directly. Okay, so first of all, we need like a generalized data modeling. So in Cyborg, we already started the effort to somehow standardize the data model. I think it's also very important for Kubernetes to have the same, so that you have a pretty good standard. This one is actually coming back from feedback from Alibaba. So for Alibaba, at the time, the only thing they can do is they put annotations or labels on the pod to try to efficiently schedule the pod. Yeah, the pod. Yeah. So the problem with annotations is that it is not standardized. So like for Alibaba, they have to maintain something like a standard dictionary or something for if you have just one type of like GPU, it's okay, right? We can label it pretty easily, but you can, if you have like two or three, then annotations, whether on pod level or node level, could be really messy. And the fifth one, to reuse existing like ICE driver if possible. This has to do like collaboration with Cyborg.
There's a point about modifying CRI potentially, right? Why do we need to modify CRI for that?
I think this is actually coming from the Intel FPGA team, Sasha. So they have do some hacking for the to be able to have pod runs on the FPGA. So
modification of cryo.
Yeah.
The restart hook has been modified.
Yeah.
That's part of cryo itself. I think there are many ways we can do it even without modifying CRI.
Okay.
CRI is kind of another core interface. If we propose more changes to the core, they're going to be. We can, if you want to leave it there, would point out as a problematic thing.
Yeah. So
there are alternatives we can discuss.
Yeah. Understood. So coming back, the fifth item is something like collaboration with Cyborg project. For example, if your enterprise already have an OpenStack infrastructure and you already deploy Cyborg, right? The goal is to not for you to develop another set of plugins for containers again. So you can just leverage the Cyborg existing drivers. Okay, so do not reinvent the wheels, everywhere. Or if you are on like AWS or Azure, as long as they can expose their heterogeneous computing management APIs, we should like be able to talk to them to leverage any existing stuff. And the last one is also very important, also part of the main complaint actually in the community is we actually need a lot of things to be reported from the device to the scheduler. Number one is topology. There are entry efforts on the topology managers, but the thing is that accelerators at the moment is more like an afterthought in Kubernetes scheduling system. So you don't, it's like, so accelerator related scheduling, most of like, if I try a single NUMA, like, and the current node is not available, but actually there are other nodes maybe available. You have to fail first and then have a mechanism to trigger the schedule to reschedule again. And many other like rescheduling is like the current, as far as I understand, is the current main mechanism in Kubernetes scheduling regarding to accelerator. For main compute is first class citizen, right? If you are not satisfied, we will keep, curing it until have it. So other than that, other than topology, like vendor information, there are a lot of them we need to report, and also power information. Also feedback from Alibaba on their edge side. They actually cared about the power consumption of the accelerators, of the GPUs and FPGAs to make intelligent scheduling decisions. So a lot of stuff need to be reported for scheduling. Apparently, kubelet is taking it deadly slow to have that capability supported. And I really think we can have this new project to be able to support this kind of requirement. Okay, so on page 2, there are some use cases. Just I came up. If you have more use cases, you're more than welcome to to add any additional use cases. It's like for example, I'm a China Mobile. I have a fleet of different kind of accelerators. How I can general manage them, or like we just mentioned, the topology awareness for the scheduling, and
some interesting comments on the point.
Yeah, that's by the way, that's from the NVIDIA team before the Huawei ban.
So they were talking about pushback from community, right? We had actually proposed a scheduler extension back in 2016.
Yep.
Right?
Yep.
We talked about that with the source management group. The feedback I got was that they will not allow it.
Yeah.
Because the scheduler itself may change, the framework is going to be evolved.
Yeah. So new thing for us is that we have another new project called Volcano, which is based upon the kube-acc project. Previously is a dedicated batch job oriented scheduler. We can utilize that. So this is something can work for us. So compared to 3 years ago, it's really nice. So okay, moving on for goals. For example, we need of course a CRD-based framework to do the API extensions for the accelerator management. This will be a auto band in addition to the DPI mechanism, not a replacement, like a drop-in replacement. Also coordinate with schedulers, like I said, for example, the Volcano project with either the topology awareness or the power awareness or any of the accelerator related scheduling stuff, and also capable of being integrated with, for example, Cyborg or other proprietary clouds. And lifecycle management, of course. So similar to Cyborg, we need the kube-acc be able to do the attach detach programming for FPGA or NP smart NICs, to do the power thing. For example, Huawei's Atlas 300 card, actually you can dynamically do the power on and power off stuff for part of the region of the AC card. It's pretty neat. And other stuff that your accelerator card can do, we want to support that in a general way, of course. Standardized modeling and policy enforcement related to like NUMA or like Affinity, all that stuff. So non-goals, we don't want to replace the DPI mechanism that's already in core. We don't want to disrupt all the core implementations. And also, kube-acc does not do another scheduler implementation. We collaborate with existing scheduler projects, but we don't do that. This is also the same lesson we learned in Cyborg, that it saves us a lot of time and debate to have our own scheduling implementation. Okay, moving on. Current design, I just referenced Intel teams their FPGA support with the current DPI mechanism. You can see the figures I borrowed from Sasha. Thank you. Thank you. It's pretty awesome, but you can see the silo thing I mentioned. It's a lot of work need to be done just to be able to have one kind of accelerator supported. So moving on, there's a proposal.
What point on this current mechanism as we have today, some limitations, right?
Yeah,
talk about it, or shall I highlight that?
You can talk about it.
Okay, sure. So this is a feasible thing for FPGAs. We have something today. The problem is this, I can see the diagram. It's admission controller webhook. So let's say your use case is that you want to find an FPGA JSON. You ask for that. In your request, the port spec is saying I want a function ID for, let's say, JSON. This webhook will go and translate it to some kind of bitstream ID instead. But when you do that, the bits, whatever bitstream ID you choose has to be compatible with the FPGA you choose. So if you have different types of FPGAs, your bitstream has to exactly match the FPGA type. That's a basic requirement. So if whatever you happen to pick, it's going to affect your scheduling decision later. Because it's going to constrain the use that type of devices. You can't use anything else if it's available. So essentially, scheduling has gotten disaggregated or decomposed. Somebody's making a decision without regard to the rest of scheduling. So if your overall part spec says, I want NUMA, I want 3 virtual CPUs or whatever, you're not making a holistic decision based on all the criteria. You're picking something and that influences the rest of the schedule. That's the issue today.
Yeah, so it's working, but it has the limitations Sander just mentioned. Not to mention the webhook thing. So moving on, there's a proposal. If you click on the architecture figure slide, this is where the picture I draw. But there's a really interesting. There's a recent conversation. There's a question prompt by Chris from the Starting X team actually on the Signal channel. So his problem is actually the kind of thing I just mentioned. The scheduler doesn't check with kubelet before assigning the pod to that node, right? So his use case is that if a node has enough CPUs in total, but not enough on the single NUMA node, and there's happened a policy set for the single NUMA node, the only thing you will get is just a failed error. Unless, as the later on point out, unless you have a external controller that doing the retriggering, it will not be automatically rescheduled according to your need. So I also add a link of the bug report on the document you can check out. This is like a vivid example of the current, the limitation of the current mechanism. So back to the proposal, this is like really high level architecture I just draw up, just give you a sense of on a really high level what we want to do. So with the CRD framework, first of all, we will have an API extension of our own API service, and the main server will listen since we will register our extended API to the API server. And another different thing is that since we don't touch on kubelet, the only way we report all the informations we mentioned topology is actually through the APIs. So for example, Volcano will register also to the API server, and we'll pass on the information we gathered that needed for the scheduling through the API server, through the API bus to Volcano. Obviously, there's a support needed in Volcano to receive that kind of information. So we can talk with the Volcano team later on, see how this thing will go. So other than that, we'll have our own like implementation of the controller logic, like lifecycle management, support of our own resource modeling for the accelerators. If you have policy enforcement, you can do that. And further down below, so we don't want to make assumption on the underlying infrastructure. So if you already like have stuff like Cyborg and OpenStack infrastructure, then we just like through a northbound plugin of Cyborg, of course, to directly utilize Cyborg. If you are running on bare metal, then there's a need for a new kube-acc plugin to be developed. And like we mentioned, if you don't have the use case of multiple accelerators, then just directly use DPI with all the core features. You should be fine. So this is a high-level general proposition.
So does the Kubernetes controller needs to be aware of that?
Yeah, I think so. Yeah.
So how could this hardware report their capabilities?
So it'll be through our own southbound plugins. Since kubelet doesn't support, we kind of need to develop our own set of kubelet stuff, but just for accelerators.
Yeah, maybe a dim side inside the Kubernetes to do this work.
Huh?
I mean, maybe a dim side or something to running on the node to report.
Oh yeah. So
another simple question. So could you elaborate what is DPI?
Oh, DPI means device plugin interface.
Okay.
It's like the CNI, CRI similar stuff for the accelerators. Yeah. So yes, we'll have. Huh? Yeah, you should be.
I have questions too. Within to repeat, for example, from data model, as you said, you don't want to use annotation. On another board, Kubernetes as a database, usually other projects do. So you want to use a direct RPC between a kube-acc controller and kube-acc plugin, right? And keep all information on the kube-acc controller side, yes?
Yeah, but mostly I think we still need to write all the DB related stuff to etcd, to the clusters etcd. So I don't mean that we don't want to use annotations. I mean, we need a standard way to use annotations instead of just giving like each company had their own way of labeling all the heterogeneous resources.
Yes, I understand. So you will have a root element like kube-acc in that annotation, and all other elements will be standardized.
Yeah.
Okay.
Yeah.
It's clear now.
Yeah. And based upon lessons we learned in Cyborg, I think we'll be needing a tree-like resource representation because the nature of the accelerators, right? We have like nested resource provider. Yeah, that kind of data modeling introduce them to Kubernetes.
Frankly saying, Kubernetes right now provides information about resources, which provides by device plugins. Resources, I mean, number of SRIV and number of available GPUs, but it's just a number, and we don't know which NUMA it belongs to. So we also need to keep a topology or NUMA topology of the host inside our annotation.
Yeah, sure.
We also need to think about how to manage the aggregator life cycle, right? Like kubelet goes and tears down a pod. Cubase needs to be informed sufficiently soon so it can go and do some cleanup or all that stuff.
Yeah, so I think we can directly go to the challenges section on the design doc.
Okay.
Apparently, it's very easy to draw a architecture picture like that, but it has many difficulties, of course. First of all, for an out-of-band solution to be able to attach anything to the pod is very difficult in Kubernetes. We tried our another storage related project. We used a service broker, so we tried with the what they call the PIP mechanism. Maybe that'll work. I don't know. That's gonna be one of the biggest challenges. Another one is, you know, how's the correct relationship with the DPI. In a really high level, I can say that, right? So DPI for just single type of accelerators, use kube-acc plugins for if you have multiple, but still we need to find a way to coexist with DPI because DPI plugins also report informations, right? So I think the most ideal solution is still to like slowly push many of the features into DPI. It's core. So I think maybe the relationship is like we have the parallel as out-of-band solution, but we still want to slowly pushing features into DPI. The core support as many as possible is really great for us.
But what if they don't want that?
Then we have to maintain. Yeah. Like yeah, the second challenge I just mentioned. It will be really a challenge to do the attach anything to the pod. And also with the collaborate with the scheduler design, I mean with the either the Volcano project, which dedicated for the AI and HPC jobs, the batch jobs, and also with the core scheduler implementations. Yeah, so that's all I have, and your comments and like this is a good idea or you are interested or how should we proceed? To be honest, I have been toiling around the idea for about nearly 2 years. The reason why I just proposed this now is we all kind of want a SIG node and the resource management working group to already do this, so that we don't want to do that. But it happens, their process is really like glacier slow. So I think now is maybe a good time that we actually start like experimenting with the like a out-of-band solution, at least to get things moving. Hopefully, like 5 or 6 years later, many of the stuff will become in core. But okay, yeah, comments or
I have one question.
Yeah.
So for maybe Atera FPGA, it should be support from the CRI side, and then device plugin side.
Yeah.
So they need to report their metadata to make the Kubernetes node, right?
Yes, the device plugin reports that.
Report that.
Yeah.
So in this controller side, just kube-acc just deal with maybe I'm not quite sure. Maybe attach or
The kube-acc plugin has the potential to report more information than what DP allows us to report. So for example, what's inside a FPGA in terms of functions or bit streams or whatever, that's not exposed today at all. So it cannot be used as a factor in scheduling a pod on a particular host. Whereas with kube-acc, hopefully you can support enough information, like Howard said, for us to influence scheduling decision itself.
So for using the FPGA, so in content runtime side, you still need to do several jobs in a maybe pre-start hope.
Yeah.
Yeah.
Pre-start hope.
Like programming and all that stuff.
I mean in OCI side.
OCI. So that's the portion probably we need to discuss. Like one way to do it is in the pre-start code, but the Cryo provides a pre-start code, but what about other container runtimes? So do we assume that every single container runtime is going to change for our needs? That's not a reasonable thing, right? So you want something outside of CRI ideally. That's just my take.
Yeah.
So I think there are some possible ways to do that. We need to kind of think through that thing, especially with kube-acc, a whole parallel chain with a lot of interesting potentials there. There's some challenges, but also a lot of interesting possibilities. So we could use the kube-acc chain to go and do some programming, or basically with some kind of custom controllers and operators could be used for it as well. We have to kind of define the whole chain. I'm just kind of thinking aloud here, but if the existing mechanism doesn't work, we have to come up with something totally new.
Absolutely.
Yeah. I would say the important thing is the existing metadata is just not sufficient. You can't simply report a string saying intel.com/FPGA. That's nothing. We have to report a lot more like what we are doing in Cyborg.
Yeah, I see.
Yeah, and for those of you not familiar with the Cyborg way of developing, we don't have any pre-existing code. So we come up with a design proposal, we agree upon the design, and it's up to you guys to start writing the code. So there's no company like code dump. I already wrote this open source. So it's
their work, but we didn't use it.
So it's a totally community-oriented development. So
I'm just curious. So are we saying that we are all potential developers? Like,
yeah, if you want.
There's interest in developing this kube-acc.
We think about it, then it's improving and scheduling because of awareness. Now it's about number of resources, also a lot of workarounds like labeling, for example, we are people enable to not like it's we not also our colleague from Victoria proposed to enable it as topology, enabling topology and the kind of CPU manager, topology manager. There are two, but it's not enough. We have to know dynamically the allocation of the resources.
Like now using some hacks just to like node labels and some hot selectors and those kind of things. So like the better integration. That's the same way which you want.
Sure. Okay. So you said you mentioned working at some parts of Intel, right? Which device are you working with? Just a general SRIO.
Okay. Yeah, and from my point of view, the SRIO device target is the same as another device targets in part of observing CSFS. 80% of those device targets are the same. And there is no specific need functionality that every device plugin, maybe change the driver or add some environment variable to code. That's all.
Plus, it's also kind of networking focused today. If you look at the config file for SRIO device plugin,
yes,
it's all networking focused. Yeah. So yeah, that's why we can't leverage it directly for FPGAs or for accelerators outside the networking context. Sure.
Yes, as the API ID is not in the SRIOV device again configuration, it's just API IDs.
That is true. I thought we also put some network
Interface names.
Like some people use it that way. I think. Maybe it's not usage.
Yeah, we also use device driver because it's important to us to change device driver for usage with DPDK. We use a user space driver instead of kernel driver, and we need to change it.
The user can request which driver should be loaded for the same device. So they can change drivers on the fly.
So would it be useful to decompose this into several use cases like Kubernetes on top of OpenStack, Kubernetes environment? We may want to have a unified vision, but perhaps we can tackle it one at a time. Some may be easier than others. Maybe.
Yeah, sure. So I think if you're interested, please leave your name and email address on the document so that we can follow up with regular team meeting and other stuff. But this is the first one.
Sounds pretty interesting.
Yeah, the idea has been tossed around with NVIDIA folks, with AMD folks, with Intel, of course. Well, all the major players. Everybody seems very acceptable to the idea. I think NVIDIA team also has a lot of problem with the topology reporting.
Yeah.
Yeah.
In terms of topology, we try to sort of migrate some of those data structures. We don't have to reinvent the data structure.
Yeah, that'd be the best.
At least we can have abstraction layer on top of it.
Yeah. So let me ask if anybody online has question. 哎，线上的有没有啥问题吗？莎莎，你看。
哎，我有个问题，喂，那个我就用中文问了啊，那个就是，对我看那个那个 high level architecture 里面，然后就是有那个 DPI 的方式，然后能够支持那个加速硬件，然后还有 kube-acc， 然后在使用的时候，这两个是一个互斥关系，还是一个
是合作？
会协调，是一个互斥关系吧？我理解。
就是怎么说呢？刚才说的就是挑战里面，其实就包括这个，就是怎么跟 DPI 做这个关系。实际上我们还是希望通过场景，就不同场景应该还是用不同的。那假如你都 deploy 的话，我觉得有可能会出现互斥的问题。但是我们还是希望能够是一个就是互补的关系。
是那个分的场景吗？就是 notes 里面那个两个吗？一个是本地部署的时候，一个远地部署的时候吗？
不是，就是一个是单类型加速卡，一个是就是多种加速卡。
不是，我是说那个就是部署 DPI 插件和 kube-acc 插件两个插件同时部署的时候，我看你们推荐的是就是本地如果是部署附着那个加速卡场景的时候，是分开的，对吧？希望能都使用。
对，是这样。
远程部署的话，
对，就是说远程部署的话，肯定就用不着 DPI 了，基本上，就是你用 kube-acc 的肯定是没问题。就是刚才说本地的时候，可能就是区分场景吧，就是这样，可能应该是现在就设想可能是区分比较好。
那个我想问的是 kube-acc 那 control 里那个策略增强，你们是指的是什么策略增强呀？
就是 affinity 这些相关的。NUMA 的这些 policy 不是增强就是策略的实施。
实施
对，要写 可能会有一个小的一个策略引擎。
你们会只是策略引擎，会涉及到具体的定义策略什么之类的吗？
可能会涉及到，因为就是策略引擎，我们也可能就让 Open Policy Agent 去做了。就是不管怎么样，我们得需要一个策略的东西，因为 Ego 是需要 policy 的。
哎，那个我想问，就是这个的话，在现有的这个 DPI 的实现里面是缺失的，对吧？
对，它会对DPI 现在应该没有 policy 相关的东西。它是通过其他方式做的啊。
对，就是说通过其他方式，其实可能也能实现一些，因为它也能实现，就是去对这个加速端的那个，就是去调度嘛，对吧？但它可能方式可能不一样，对吧？
对。
你们的，
因为就我再问一个问题，就是我理解，其实 DPI 的话，它也能接不同的硬件，它只是就是说是会就是需要去插不同的那个就是要装不同的那个 driver 嘛。
对，
吧？
而且一次我理解它也应该是不能多种加速卡同时使用的，它应该就是你用哪种，就是它只能支持一种。
对，那我理解就我的疑问就是说，它这个是对，比如说一台逻辑上它不同的那个加速硬件就是的管理，还是说就是我一个池子里面，然后
没有，它没有
服务器，
它肯定没有池子的概念，池子只能是我们这种方式做。
就你们这个方式就是说是可以，就是说
对，我们就是要做池子的。
对，这个池的概念是指说是一台逻辑上，还是说一个资源池里面有很多个服务器，然后每个服务器上面的那个加速卡都不一样？
都可以，就是说
都可以是吧？
你要不就是一个服务器上，我可能不同，就是我服务器的规格上就有不同卡槽，或者是同样的卡槽我插着不一样的，或者我单独有一个框，就是拉远的以太网联的框里面是不同的加速卡，都可以，无所谓。但这个其实是我们就是我们这种设计是比较好去做这种场景。
所以我理解，其实库贝 CC 就是可以说它的核心区别就在于它是对那个就是我理解啊，对于这个 DPI 的这个使用或者说它的能力进行了扩展。
对，其实是一个补足，对，
一个补足。那我想问的就是，其实你上面刚才也提到了，就是说这个未来怎么去跟这个 DPI 这一块他们的工作，然后去做一些那个协同，或者说是一些合作什么？因为我不确定，就未来 DPI 这一块它会不会也会去做一些扩充？
就是刚才说，我们的目标其实还是希望把我们很多实践逐渐能推到 DPI 里面。
推到 DPI 里面。
对，因为它毕竟是 core feature， 但这个过程可能会极度的缓慢。所以这样的话，我们不如先有一个代外的一个方案，就是你毕竟这些创新什么的，你要有一个地方去做嘛。
对。哎，那你们的计划是把这库贝 CC 推到这个 CCF 社区里面吗？
具体放在那儿无所谓，但这就是一个 K8的一个扩展项目，当然可以考虑直接到 CNCF 去托管，也可能，不过这是后话了，这治理的问题，不是开发的问题。对。
明白。行。
OK， 就是
陈社长那边还有问题吗？
就是我感觉就是底下那个资源模型，资源模型，加速器的资源模型可能会跟 Cyborg 那部分的资源模型是不是会有一些重复？
我们会重用，尽量就是
直接重用是吧？
对，直接重用。
明白了。
对。
哎，好。
So just quickly recap the Chinese question just asked online. The folks from CMCC was asking about, for example, the relationship with the DPI plugin, like we just mentioned. So on the notes, actually, for accelerators, there are two major scenarios: the locally attached and the remotely attached, right? I think most of the problem will arise in the locally attached, like PCIe I think we need to coexist with DPI, like depending on the scenario. Like we mentioned, if you just have one kind of accelerator, just use DPI. If you have more, use the kube-acc one. So if you deploy both, probably there will be competition because of similar functionalities. But for the remote attached accelerators, I think that's the field of kube-acc mostly, because DPI has not been even thinking about. I think all the RDI may connect, for example, if I have a box of accelerators, like GPAs or FPGAs, all in one box, have a like dedicated pool. So yeah, that's kind of the clarification of the like at least thinking of the relationship with the DPI. Other questions were asked about, for example, the data modeling. We still want to like reuse as many as possible of the existing work we have already done in Cyborg to like harmonize the resource modeling on different layer, because accelerators are the same, right? You don't really need like really different resource modeling for container or for virtual machines, for bare metal machines. There will be subtle differences because the DB choices or whatnot, but we still want to, as much as possible, synchronize all the modeling we have. There were also questions asked about the policy enforcement. I think we'll need define set of the policies for the accelerators. How do we enforce them? But I think we can utilize out-of-band policy engines like OPA, Open Policy Agent, if if needed, or we just have very simple, a really simple policy engine. Just parse the requirement, dump it. Yeah, it can be done. So yeah,
JP, not so clear. Are you going to reuse already implemented Kubernetes GNOME methodology and CPU manager policies as is it original going, or you want to implement and to define your own set of policies?
We definitely want to like leverage any of the existing. We have the NUMA policy now, right, for the scheduling. But if there are like new stuff, for example, many of the ASIC chips, they might have like new areas of policy needed, then we can add things more. The principle is try not to reinvent the wheel as yeah, so if you're interested, please sign up on the design doc at the bottom of the doc with your name and email. And I'm also try to like take over the resource management working group if possible. And if we can take over the job there, then we can just reuse the resource management meetings. If not, let's like come up with a time that could work for Europe, Asia, and the US. And maybe we have like bi-weekly meetings.
Shall we add a section here for no attendees or no participants?
Oh, sure. The doc is open to everyone to edit, by the way. I think so, right? You can edit, right?
Yeah, I can.
Yeah.
Sometimes the issue is in accessing Google Docs from here. Apart from
yeah. Okay, for online participant, I will end the Zoom call now. Thank you for your dialing in.
Thank you.
Oh, thank you.
Recording will be posted.